In this video, we will solve a problem on how to find golden rule level of capital. This question is related to Solow model. The question is, consider an economy with production function given by f of Lk is equal to L to the power 2 upon 3 times K to the power 1 upon 3. L and K are the labor and capital in the economy. And we have 10% annual rate of depreciation. Find the golden rule level of capital stock for this economy. Okay. So we need to find out the golden rule level of capital stock. The options are being given. We need to find out the correct option. Okay. Now, by this golden rule, what we mean? It is simply the steady state value of capital per worker that maximizes consumption per worker is called golden rule of capital. Okay. Now, what we are being given? We are being given this production function that is f of L K is equal to L to the power 2 upon 3 K to the power 1 upon 3. Okay, this is our production function, aggregate production function. Depreciation is being given us, and let us write it. Let us denote del denotes the depreciation, which is 10%, and 10% can be written as 0.1. This is our depreciation level. Okay, we need to find out the golden rule level of capital stock. That means we need to find out the K star gold. Okay. Now, as I have told you, the steady state value of capital per worker that maximizes consumption per worker is called golden rule level of capital. That means first we need to change this production function into intensive form. That means in terms of per worker function. And it can be shown if we divide each term by L, this also by L, this by L, and this also by L. What will it become? This very function. Okay, we are just trying to convert it into out per worker function. So f of L, L upon L is 1, so we are left with K upon L. And let us write this K upon L. Okay, let us denote it by K. It is capital K. Okay, so K, sorry, we have this K first, green K upon L. Let us let us denote it by this small k. Okay, so this small k denotes our capital labor ratio or capital per worker. Then this function can be written as let us denote it by f of small k is equal to L upon L is 1, so k upon L again is equal to k, this small k to the power 1 upon 3. Now, using the identity, national income identity, that tells us that our output per worker, and let's denote it by y. Okay, let us say this is equal to y. F of k is also equal to y, should be equal to the consumption per worker plus investment per worker. Okay, here this output per worker is actually our steady state output per worker. By steady state, what we mean? When the capital stock is not changing at all. I have explained this all into this introduction to the Solow model. You can check out that very video also. Okay, so our steady state output per worker should be equal to steady state consumption per worker plus steady state investment per worker. Solving for C, that means our C, that means steady state consumption per worker will be equal to steady state output per worker minus I, and let us denote it by star, star and star. Okay, that gives us y. C is equal to, so output per worker can be written in this fashion also, that is f of k star is equal to, so k star denotes the steady state capital per worker. Now in place of I can write del k star y. As I have told you, in steady state capital stock does not change, that means our investment is equal to depreciation. Del K denotes our depreciation. Okay, so let me write it also here. So in steady state capital stock does not change, that means our investment is equal to depreciation. That is why I have written in place of I as del K. Okay. So our question is consumption per worker is equal to f of k star, that means output per worker minus del k star, depreciation. As I have told you, golden rule level tells us that the steady state value of capital per worker that maximizes consumption per worker is called golden rule level of capital. Okay, so we want to maximize our consumption. Okay, so our endeavor is to maximize consumption per worker. So the question is, we want to maximize consumption per worker, which is equal to f of k star minus del k star. Okay, so what is our f of k? Let me write it here. Our f of k star in intensive form, we have written it in this fashion: k to the power 1 upon 3. Okay, since this is a question of maximization, first order condition for maximization requires that the partial derivative of consumption function with respect to steady state capital per worker should be equal to 0. Okay, that means we differentiate this function with respect to capital per worker and set it equal to 0. Now derivative of f k star is simply f dash k star, okay, minus derivative of k star is 1, so we are left with delta here, which should be equal to 0. Now f k star is equal to this, that means f dash k star is the derivative of this function with respect to k star, that is 1 upon 3 k to the power 1 upon 3 minus 1 by power function rule, it becomes minus 2 upon 3. So in place of this f dash, I can write this 1 upon 3 k star raised power 2 upon 3 should be equal to, transposing it here, it will become plus delta. Okay, the value of delta we also know. Delta, the depreciation rate is 0.1, so we can write it in this fashion: 1 upon 3 k star raised power 2 upon 3 is equal to 0.1, or it is minus here, okay, negative, sorry for this mistake. So I can write it in this fashion: 1 upon 3 k raised power 2 upon 3 star obviously should be equal to, so this is 1 upon 10 here. Now reciprocating both sides, so we will get 3 k star 2 upon 3 is equal to 10, or k star 2 upon 3 is equal to 10 upon 3. That gives us k star is equal to 10 upon 3. Transposing this exponent, it will get reciprocated. If it is 2 upon 3, it will become 3 upon 2. That means our golden, that is k star gold is equal to 10 upon 3 raised power 3 upon 2. This is our golden rule level of capital. Okay, the condition for golden rule level of capital, and here you can actually see it here. When we take derivative of capital per worker, okay, first derivative, what exactly do we got? We got the marginal product of capital, and del denotes the depreciation. Okay, so at the golden rule level of capital, our marginal product of capital should be equal to the depreciation rate. Okay, So if you want to simplify it in shortcut, you can use this very expression, that is marginal product of capital should be equal to depreciation. That will give us the golden rule level of capital. Let's graph it out. Okay, that will make more sense. So we have capital per worker on the horizontal axis, and we have output per worker on vertical axis. Okay, so given our production function, let us say this is our production function f of k, this is in intensive form. Okay, we have this del k. Okay, now our golden rule level of capital, as we know, as I have told you, our marginal product of capital should be equal to the depreciation rate. When the slope of production function, our capital per worker, and the slope of, what we call this depreciation are equal, okay, that very uh, their 2 points give us the consumption that is maximum. Okay, so this gives us maximum consumption when the slope of out what we capital per worker and the slope of depreciation is equal to, that gives us consumption, maximum consumption, and that will be our k star gold. So this denotes the k star gold. Why? So up to this, it is our y, that is total output per worker or output per worker, and this thing up to this, it is our investment. So when we subtract output minus investment, we get the consumption. The greatest difference between these two curves, where it has the greatest difference, gives us the golden rule level of capital, and at that point our consumption per worker is maximum. Okay, so uh, and this thing, okay, and let me write it here. We have f dash k star is equal to del, and f dash means the marginal product of capital should be equal to differentiation. So okay, here marginal product of capital, this point denotes mpk is equal to del, that means slope of this f k should be equal to slope of this del k. Okay, so it happens at this point. I hope I make myself clear. Thank you.